here we're going to look to write an equation of a parabola. You'll find this is the same as the previous video we did. You're just looking at this in the context of a real life problem or a real world scenario, where the other one was just, outside the context of a real world problem. So your process is the same. In this problem, we have the height of a thrown ball is a quadratic function of the time it has been in the air. The graph of the quadratic function is the parabolic path of the ball. The vertex of the graph is 120. We can see that on our graph, and the path of the ball includes a point 0.04. So when you're throwing this ball, you're releasing the ball from 4 feet in the air, so that's why it's at 0.04. What is an expression that defines this function? So let's make some notes for ourselves. We have some scribbles here that we need to get rid of, but we have a vertex of 120. Remember that is h and k. And we have a second point of 0.04, and that would be our x and y values. Okay, so we have h, k, x, and y. And we're going to do the same thing that we did in the previous problem. Y is equal to a, x minus h squared plus k, and we substitute our values in. So y is 4, a is what we're trying to solve for. Let's use parentheses. X is 0. H is 1. So we're subtracting 1 here. And K is 20. Now, you might notice in this problem that the parentheses really aren't going to make a difference, but it's always a good practice to make sure when you're substituting, you use parentheses to avoid some easy mistakes. So 4 is equal to a times 0 minus 1 squared plus 20. 0 minus 1 is negative 1. We would add 20. Negative 1 squared, we know that is 1, so we have 1a. Make sure if you, for some reason, type negative 1 squared in the calculator, that one you should definitely not, but in regular negative or another negative, be careful, make sure the parentheses go around the negative 1. So, and then we would add 20. So we'll subtract 20 from each side. If negative 16 is equal to a. We no longer need that 1, right? 1a is the same as a. So my a value is going to be negative 16. It does make sense that a is negative because we do have a graph that's been reflected. So that checks out. We can't confirm that negative 16 is the answer just by that, but it does check out that it should be negative. If I came up with a positive a, then something would be definitely wrong. All right, so we have our a value, and we're going to write this back in vertex form. So y equals a times x minus h squared plus k. Leave y as it is. Substitute a. Substitute h. And substitute k. So let me highlight that. So a was negative 16. H was in blue, and K was in red. Right, clean this up. So negative 16, x minus 1 squared, plus 20. All right, and that is the expression that defines this function. So we can have that highlighted. Now they also ask us to write the quadratic equation in vertex form and in the form y equals ax squared plus bx plus c. You won't always be asked to do this. In this example, they are asking us to do it, so I'm going to show what you would do, just so you have an idea. But most of the time, they're not really going to ask that. So to do that, you would take your negative 16, x minus 1 squared, plus 20, and we're going to multiply all of this out. So x minus 1 squared is x minus 1 times x minus 1. So we'd have negative 16, and then we could use our FOIL method. So first, outer, inner, and last. Clean up the inside. Distribute the negative 16. Combine like terms. And we have our y equals, so this should be y equals. Again, you won't usually be asked this, that's why I'm kind of rushing through this part. We're really concerned with this. This is what you want to be able to do here. Right. It is going to be useful to convert back and forth from vertex to ax squared plus bx plus c. But for this video, focus on this here. Again, don't worry too much about what's going on in the other part there. Oh, it's going to be a pain to erase that. Oops. There we go. All right, so that would be our second part of our answer. And that is it. So example 3 and 4 are done the same way. The only thing they added was this ax squared plus bx plus c. Don't worry too much about that. Again, it's just a series of multiplying, distributing, combining like terms. Just make sure that you can plug in y, x, h, and k to solve for a in order to get your function, your vertex form. Right, that's it for example 4.